It's really hard in organic situations to advance carbon levels because every time you till, you're releasing CO2 into the atmosphere. We work a lot with organic producers, and the challenge is how do you minimize those tillage passes? Because tillage will always, it'll decrease soil structure. It'll actually increase compaction right below that, whatever depth you're tilling to.
Yeah.
It'll decrease water infiltration. It'll increase weeds because we're disturbing that.
Yeah.
And it's gonna decrease mycorrhizal fungi. And this is where the education process comes in. You see what's happening right along these roots here. This is actually really good. Right here, mycorrhizal fungi form an association with most plant roots, not brassicas. And mycorrhizal fungi, think of them as the streets and avenues in the soil. They're going to move nutrients throughout the soil profile. They connect to multiple plants. Well, mycorrhizal fungi secrete a glue called glomalin, and that's the sticky substance that, along with secretions from biology, start holding the sand, silt, and clay together, start forming these aggregates. This is called the rhizosheath. This is right along the root. It's that interface where these little plants here are capturing solar energy, photosynthesis occurs, they use part of it for growth, the rest of it they exude out into the soil to attract biology, and it's the biology that's bringing nutrients to the plant. Now here's what most people don't realize. A soil aggregate, so this soil aggregate is sand, silt, and clay bound together by that glomalin, the sticky substance. They'll only last about 4 weeks, and then biology will consume it. If you don't have a living plant, mycorrhizal fungi, and biology, your soils are going to get more and more compacted over time. Okay? Look at this soil here. It's not well aggregated. Now, if you would hold this for me, I'm going to walk right over here, and I'll be right back with another. Okay, now look at this soil.
Oh, wow. Yeah.
See all these aggregates? Okay. Every one of those is a soil aggregate. Okay? Now, let's compare here.
Oh.
Do we got a difference? So which is going to infiltrate water faster? That's pretty easy to see. Look at the color difference. Which has more carbon? Now here's what's extremely important to remember. Bill, what do you care about? Money, right? As a farmer, we want to make money, right?
That's the whole goal. Yeah, this is my job.
So what I'm going to recommend you do here, Mike, is besides the testing that Yardstick's doing, you need to pull a Haney, a PLFA, and a total nutrient extraction test. They're not that pricey, just on one of these fields. Okay? Then that will prove to you that I'll guarantee you already got enough nitrogen, phosphorus, potassium, and minerals. You don't need any more. We did over 200 different farms this past year. The average nitrogen in the top 12 inches of soil profile was 9,000 pounds. Okay, phosphorus 2,300, potassium 11,000. But it's not available. In order to become available, you have to have biology. Okay, which ones is more biology going to live in? Okay, biology lives in and on thin films of water in these pore spaces between the soil aggregates. All biology in the soil, microbiology, is aquatic. They live in water. Well, which is going to have more water in it? So, this is one of our pet peeves. You know, people put in drain tile. We got to drain the water. Well, why not just build soil that'll drain the water? And the thing is, we can build this down 4 feet, 6 feet. However deep you can grow plant roots, you can build soil structure like that. So the more aggregation, the more biology, the more of that massive amounts of nutrients you can make available. So people wonder, okay, what's the difference between understanding ag, other companies? Other companies are trying to sell you synthetic fertilizer or amendments, whatever. No, we're trying to educate you, show you through that test, Mike, that you've got the nutrients, Bill. What you need is the biology to make the nutrients available. Does that come? Can you enhance it all in 1 year? No. It's a weaning process. But here's what else they don't understand. Soil is 1 part nitrogen, 11 parts carbon. So if you're adding too much nitrogen, or as your very intelligent wife understood,
Say that again. What was that?
as your very, if you have too many legumes in the system, this is one of the problems with corn soybean rotations. This is one of the problems with alfalfa for hay. You're producing so much nitrogen. Well, for every 1 part nitrogen, the soil needs 11 parts carbon. The biology is going to consume the nitrogen, but then it's going to start consuming carbon. It consumes all the carbon in the aggregates, consumes organic matter, consumes the dying, decaying roots. Pretty soon you end up with a brick. Now you've got some inherently good soils here. I can just tell by looking at them. So to regenerate those can happen pretty quickly. But I hate to tell you, but you just gotta minimize the tillage. That's the one thing. And I understand why you're doing it for organic, okay? But in order to get this type of soil structure, you move this to this, you gotta stop the tillage. Because that tillage, every time you till, you're releasing that carbon. There's not enough carbon to feed the biology.
Think about all that free time in June.
Yeah.
Hello,
Do you know how
Saturday.
nice that is? See, we haven't had to use on our ranch, we haven't used a pound of fertilizer of any kind since '07. Okay? Nothing, zero. That's a lot of time, dollars, everything saved. So, really adds up. But that's the basics of what we're trying to do. So, that's the principle of least amount of mechanical, chemical disturbance possible. Next principle, armor on the soil surface. You gotta keep that soil covered. Okay, why is there so many weeds in this field? Okay, I'll tell you, okay, in my estimation why that is. Number one, you tilled to put the soybeans in there, correct? Yeah. So it was bare soil. Nature's gonna always try and cover the soil. Look at home gardens. Why do you get weeds in your garden? 2 reasons. Number one, most people till, so it's bare. Nature's gonna cover it. Second reason is too much nitrate nitrogen in there. Nitrate nitrogen will cause a flush, particularly of broadleaf weeds. That's why in that hayfield in back where we were yesterday, and I saw the thistles in there, I think I mentioned to you, Will, I could tell that I guarantee you test that, it's going to be high in nitrate nitrogen. And that's what's causing those weeds proliferate when there's too much nitrate nitrogen. The goal then is to grow grasses and that'll cycle that into the organic form, and then they'll release it to biology, make it available slower. Otherwise, nitrate nitrogen is just going to volatilize or leach out of the soil profile, and you'll lose it. So we want armor on the soil surface. That's third principle. Fourth principle is diversity. Now, this is a rye cover crop. Difficult to find many fall biennials that will fit in with that. You could have put a little vetch in there, a little clover in there, but because he's going to combine it for grain, I'm not going to say that, scold you for having a monoculture here. Makes sense in your situation. I got to step back. One thing though, when we talk about armor on the surface, I would not recommend selling the rye straw. I know it's worth money, but that armor is worth more to you than. Last time we figured it up in every bale, just in the nitrogen, phosphorus, potassium, you're sitting with about $80 per bale in
But you
round
said
bale.
I have plenty of that anyway.
Yeah, but that's how much nutrients you're giving away then. So, you know what I mean? Yep. So,
If I get $5, I'm not giving it.
how much?
$5.
And
These are little idiot
Six
blocks.
if I sell it.
Yeah, I'm talking about a round, obviously, but yeah. But equate that out, you multiply that times 20, and then figure what your carbon's worth, and then figure what the armor's worth. Because what armor on the soil surface does is it's like our skin protects everything underneath, and that biology needs that. It needs that to feed on. It needs that to keep soil temperatures optimum. Here in our northern environment, we're not quite as concerned, but I guarantee you on summer days, I can come here and bare ground, I can temp it at 150 degrees. And bare ground, you're killing biology, you know?
I think this is a remedial question, but you would if you were going to keep armor on, you would combine it and then you would
Just spread it.
Just spread it.
Yeah.
Or crimp it, or no?
No, you can't
No.
crimp it if you're gonna combine.
Yeah.
Combine
Well,
it.
That'd make difficult
Yeah, that's what I
combine.
suppose.
Yeah.
But
Yeah.
I suppose that's
It'll just spread out the back of the combine. Yeah. I would keep residue on the surface. So the diversity, not very diverse. This is very diverse. That's why this is actually showing up to heal the soil, this amount of diversity. And people think, oh, we got to go in there, we got to spray the weeds, we got to get rid of them all. I can understand it from combine and a crop perspective, but you got to understand nature's trying to heal itself is why that showed up. And so the diversity is the balance that nature has. Every one of these plant species sends out different root exudates to attract different biology. And so the more diversity, the more root exudates, the more you're going to cycle nutrients to provide to the plants. What's amazing that most people don't realize is, okay, here we got a grass plant, and then there's a soybean plant. Here's a couple broadleaves. These plants can sense what the plant next to it is sending out for root exudates. Oh, my neighbor here is sending out root exudates to attract biology to bring potassium. I'll send out root exudates to get iron, for instance. They actually can sense what the other one's doing. And then another thing, I talked about mycorrhizal fungi, these plants being interconnected. They've done studies in soybean fields, and they took like soybean aphids, and in healthy soil with good mycorrhizal populations, they put soybean aphids on the far end of the field. Within 5 minutes, the plants on the far end of the field were sending off signals to attract predator insects that feed on soybean aphids, because they got the signal through the mycorrhizal fungi to do that. We haven't had to use an insecticide. I haven't used it in over 25 years. Do I have pest insects? Yes, but you need some to feed the predators and keep their population so they can feed on those pest insects. For every insect species that's a pest, there's 1,700 that are beneficial. So in agriculture, we focus on killing that pest, spraying. That's the worst thing we can do. Worst thing. Doesn't matter in our garden or in the field. The next principle is living root in the soil as long as possible throughout the year, and Bill's obviously accomplishing that here. I showed you on those roots how many aggregates are being formed. He may not realize this, but that is huge for the following crop. It's huge not only for this rye crop, but the following crop, the energy that's cycled to drive production. And that's how come I haven't had to apply any nutrients in 14 years. You know, you can do that, and we can do it very profitably. And people say, yeah, but my yield is going to suffer. And I'll say, but that goes back to context. What can your environment handle sustainably? We are, today in agriculture, we're outproducing our environment. We're adding too much nitrates, inputs. Yes, our yields are high, but we're trashing our soils. We're trashing our ecosystem, which is why you're here, which is why Yardstick's here. How do we get more carbon, heal the ecosystem? This is a start, living plants. And then the final principle, the sixth one, animal integration. And you know, I'd love to see animals on every acre because they will take soil health to another level. That's not always possible to do. If not animals, at least have the diversity to attract beneficial insects in that, because that's just huge. Proven fact, if you have a hive of pollinators, whether it be bees or native pollinators, within a quarter of a mile of any field that needs pollinating, you're going to see a minimum of 10 to 15% yield increase. You know, that's huge over time. It's things like that that really add money without doing a lot of work, you know. And then especially if you can market honey and things like that, it's just win-win. But even the natives, with the structure woods and that you have here, you're going to have a lot of native pollinators. You know, you have beautiful habitat here to have a healthy ecosystem, and it already is. I mean, I've seen, you know, Bill, don't get upset. I'm not trashing what you're doing, because as I said, your soils are inherently good, and what you're doing here with the diversity and with the rye covers and that, you're maintaining. I'll put it that way. So what do you observe? What do you see?
Diversity.
Yeah.
That's right. There is some diversity here. What else do you notice about this?
Leafy stuff.
That armor on the soil.
Not enough armor at that.
Not enough, but some. Better than that tilled field right there, right? So there's a lot of positives, but what I see here is nature trying to do what Bill didn't do. Now, Bill could say, no, I was just smart enough to allow nature, and that's fine. That's fine. I'll give you that one. Now, I would like to see more grasses coming than what's here, just to build soil aggregates. Your fibrous root systems are gonna improve soil health much quicker. See how this breaks?
Layer.
Now compare that to that grass piece I brought. Same thing, right? How much water is going to infiltrate? How much carbon is there? So the challenge, and people always ask, okay, the farmer's concerned about profitability. The ecologist is concerned about more carbon in the soil. Well, we can do both. You know, it's not that difficult to increase profitability while improving the ecosystem. So if you want to focus on carbon on this farm, number one thing, have to reduce the tillage. That's just by far the number one thing. Second thing is a few less legumes in the rotation, more grasses. And Bill, you have the ability as a farmer, what we encourage our clients to do is, you don't have to go buy all these cover crop seeds. You're selling rye, beautiful cover crop. You could grow oats, have that. It's pretty cheap to go into the bin after you combine this rye off and just take some bin run peas, some bin run oats, something like that, seed it. The other problem you're gonna have though is you're gonna have just deer camped to no end on this stuff, you know.
This back here.
Yeah, I bet you will.
That's one of those pests you talked about.
Yeah.
They're not insects, but they're pests.
But obviously you're not grazing livestock on here, but
Yes, I am. They're called deer.
yeah, exactly. That's my point. If you have high populations of wildlife, there's nothing wrong with that.
They don't seem to really hammer on the rye, though. The rye was looking good here all the way to the back end.
Uh-huh.
You try to plant corn here,
Yeah.
that back end is gone.
Yeah.
Like I mentioned yesterday about that
Yeah.
rye field back there.
Uh-huh.
The corn was half eaten when I chopped it.
Yep. So what are we doing with those 6 principles? We're driving, there's 4 ecosystem processes. Number 1 is the water cycle, and I showed you the difference in aggregation. That's how we improve, those principles improve the water cycle. Second ecosystem processes is the mineral cycle. The more aggregates you have, the more biology, the more nutrients you're going to make available. That saves you significant dollars, you know. And third one is the energy cycle. So it's all about photosynthesis, carbon. This is where the carbon comes into play. Living plants cycle that carbon out of the atmosphere into the soil. You know, part of it for growth, part of it into the soil. That's storing the carbon we need. And it's that carbon that really feeds biology, drives the whole system. And then the fourth one is called community dynamics. That's all the diversity, plant life, animal life, microbiology, everything. But you have to be doing the 6 in order to drive the 4. And what we do is just educate people, help them move down that path in a way that they're comfortable with. And different people, everybody's got a different aversion to risk. You know, I've worked with clients where first year, 8,000 acres of covers. I got one client. Yep, makes sense to me. Let's just do the whole thing. Then I get the next guy, like I said, 5 acres over the hill, doesn't want anybody to see. That's fine. We'll work with whatever. But the important thing is you got to commit for about 5 years, because so often the soil starts changing and the people get nervous. The neighbors start talking about them. They feel pressure, peer pressure, and they're like, no, I'm not going to do this. Those that stick in it will be able to, with most clients, increase profitability first year, because we're going to be able to save you fertilizer costs, insecticides, pesticides, etc. But then they just get kind of scared that of what their neighbors are saying, things like
No,
that.
I ain't worried about that.
Yeah.
I do like to keep the fields looking decent. Like this is embarrassing to me to have
Yeah.
soybeans that look like this.
Yeah.
But I've dealt
just
with
have
that
to-
for the last, since 2006, having weedy
Yeah.
fields and taking the grief, and I haven't bailed on it yet.
So the question I have for you, and I'm in no way railing on organics. As I said, we have a lot of organic customers, but are the premiums you're getting for that worth that?
No.
Okay.
No, the only thing that I actually need the certificate for currently is to sell that mess to what I take out of there and the corn.
Yeah.
The rest of it could
Yeah.
just be.
But what's organic corn selling for now?
Well, it was up a little bit. I got like $9.50 or $10
Yeah.
for it this year.
Last year I averaged just over $15 on my regenerative corn.
And who do you
Selling
market it to?
Yeah, I market it to those who want non-GMO corn.
Really?
And yeah, there's a pretty good market out there. You got to look for it. Yeah.
And you don't have to deal with the
I don't deal with
condescending asshole
anything.
inspectors.
None of it. So that's what we look at when we go on farms. And I guarantee we walk into the other fields, we're going to see the same thing. And people, oh, but you don't understand. My farm's different, soil's different. No, it's all the same.
Hello.
I don't care where I go in the world, as long as it's land, it's going to be the same thing. And we'll see the same thing, the same principles. It all applies. So, how quickly and how much carbon can you sequester? If you go down a path with a diverse crop rotation, if you're growing cover crops and integrate livestock in the northern plains here, Wisconsin and west, you can do a 0.5 to 1 ton of carbon per acre per year is what we're finding. That's about it. Now, if you're in a grazing system, really well managed diverse grazing system, we're seeing from 3 to 5 tons. And the difference is the root biomass in an annual system versus a perennial system. The perennial system is going to have roots 6, 8, 10 feet deep and more, plus more biomass. You're able to take much more in. And realize with the grazing we're talking about, you're not grazing it this short. You're grazing it much taller, and that leaves a lot more leaf area, so you're cycling more solar energy. So you're putting more carbon in the soil. Marked increase. This is exactly why this, climate change could, to a large degree, I'm not saying completely, but to a large degree, if we just change agriculture and go to more diversity in perennials, you can heal it much quicker than they think possible. And we're proving that out. As I mentioned yesterday to you, we got data from the southeast, from Saskatchewan. We're getting data in the northern plains now that's proven that out. So that's what we're seeing. Now, you get into more drier environments. You get into western North Dakota, Montana, Wyoming, western South Dakota. If you're in a cropping situation, maybe 1/5 of a ton per acre per year is about it. Yeah, it's because it's water driven. You need the biology. You got to have the living plants, and yep, big difference. So, yeah.
Kia.
This is what's just wrong with agriculture. Farmers go every year and keep spraying, if that spray works so good, how come they have weeds the next year, right? It should be,
I can go
eventually you should run out.
I can go one step further. Talking to the town, our Salem Township, they like to spray the brush along the road.
Yeah.
And that's going to come. Just why? Don't ask me. They do. They spray overhanging branches with some sort of killing stuff. And then they come in a couple months later and mow that same area. But they do it every year. I'm talking to one of the town board members. I said, why are you doing this? And I told them they couldn't do it on my property because it's organic several years back. But they keep doing it. And they said, well, that keeps the brush under control. I said, why do you have to do it the next year then?
Yeah.
Why do you, and he's a crop farmer. It's like you spray your fields, but you spray them again the next year. So what makes you think you're gaining anything?
See, that's the whole fallacy. You're exactly
But
right.
it's like a chemical company lobbyist has gotten
He's
into
like, I got a nice
the
gig here, man.
government.
Like, don't be asking too many questions.
The government's ideas of how to take care of the road ditches, it makes no sense. They spray it, then they mow it off. Wouldn't the mowing off be enough to control the brush on the ditch?
So my question is, isn't that the definition of stupidity? Doing the same thing over and over and expecting a different result. You know, right?
I think that it's just this tweaking. It was like when you said cows, we forgot that cows can walk. You know, it's just this, for some reason humans get stuck in a way of thinking sometimes, and then it's these very simple concepts that make us go, oh, of course.
Yep.
It doesn't, it's obviously not that difficult, but I didn't think of that.
Yeah. So let's talk about, we're coming at this from two different approaches. Bill wants to make money. He wants to do what's right for the resource, but you want to make money. You're a farmer. Okay? Will wants to do it for the, we need to save humanity. Let's get lower carbon in the atmosphere, right? So how different is wanting increased profitability and wanting to put carbon in the soil? There's no different. It's all living plants driving. I explained to Bill how building soil aggregates, increase biology, make more nutrients available. With the TNE test, Mike, we're going to be able to prove the amount of nutrients are here. And Bill's going to come, see, there's nothing. But I'll be willing to bet my ranch already against you that there is plenty. Okay? So, Bill wants to increase
That's on film.
profitability. We can do that.
I might end up with 6,000 acres in New York.
I don't know about 6,000, but you'd have a good time.
Well, and to be clear, it was vague on the other end. He said plenty, right? So this is open to interpretation.
Plenty for profitable crop production. How's that?
Okay.
Okay.
Well then.
So you can get what you want by focusing on, let's plant the species that'll help the soil, that'll drive that nutrient cycle, mineral cycle. You get what you want because planting that takes more carbon out of the atmosphere, increases carbon levels. Yet how come when I go to Washington, they both look at me like I have no idea what I'm talking about. Yeah, they just want to fight with each other, and it's like, you idiots. Yeah.
You got that summed up, right?
I mean, what you were saying is the carbon it's one keystone, but it's only one piece. And to me, it's also, it's only important, or it's interesting because it could be this financial incentive lever because the zeitgeist is so on it. And we're trying to learn how to measure it better. And it's obviously you're doing so much more biodiversity, all the nutrient cycling, water holding, etc.
That lake right there. Where does the water go from this hilltop here?
And that lake's a mess.
Into that lake, right? So we're working with large watersheds, estuaries. Look at the Great Lakes, Gulf of Mexico, out on the west coast, the estuaries. Major problems. Look at Lake Erie, you know, city of Toledo, Cleveland, major water problems. We're seeing that here in Wisconsin. What's that lake? Red Lake? They've had problems around the lake. They had me come speak there a number of years ago.
Oh, east and east. South
No. It's just right east of you here a little bit.
East of here?
No, it's not Pepin.
We're looking at like
No. It's Red Cedar.
Up
Red
by
Cedar
the-
watershed.
By O'Galley?
Yeah.
Yeah.
The Red Cedar, that whole community, the landowners farmers, the people, homeowners along the lake were upset with the farmers because of the nitrates. Well, they were just fighting, just like our Congress does. And I went there and I said, look, you both want the same thing. Farmers, you need to hold your nutrients on the land. Why do you want to see them wash down to the lake? But I said, homeowners, you need to help the farmers. Right now, there's just no profitability in ag, so why not work together? So what they started doing is using some of their funds to pay farmers to plant cover crops, hold the nutrients, and I haven't talked about that. You asked about, okay, what should have I planted here or whatever. Just that oats would hold you more nutrients. And what it's doing is it's converting, see, nitrate nitrogen is the inorganic form. It's water soluble. So that can leach away, and by next spring it'll be down in the lake. You plant that oats or fall cover crop, rye in this case, that sucks up nitrogen, holds it in the plant, even though those oats die. Then the next year that'll be there, and the biology will cycle it through. It'll be available for the next crop. So you're going to hold the nutrients. It's a win-win situation. This is how you increase profitability while getting the ecological results that we need. Yeah. And we can do this everywhere. I got one client in Idaho, just spring, I saved him $570,000 in fertility.
Wow.
And his crops this fall were every bit as good, but much more profitable, because he saved $570 on inputs that he didn't need.
Yeah, it's astounding.
Farmers are over applying.
You should work on a commission.
10%,
that'd be a good paycheck.
Okay, yeah. I would do it for much less than that. We save people a lot of money. But it takes a change of mindset to a biological mindset versus a chemical. There's two ways of looking at it. Current production ag is very good at producing yield in pounds, as I said yesterday, but it sucks for everything ecological. And we've got to get away from that.
But this particular land we're standing on hasn't had any chemicals or chemical fertilizer
Right.
since before '06.
Yeah, and that's great.
It has had gypsum,
Yeah.
and it has had sulfate of potash.
Yeah,
But
Yep.
other than that, I can't even afford organic fertilizer.
right. But it's had tillage,
Yes, it has.
and it's had high amount of legumes in the rotation.
Yes, it has.
So those two, yep. So that's why I said, Bill, really for you to make the switch is going to be much easier than your conventional farming neighbors, because you're already partway there. I'll guarantee you when we do a PLFA test, that stands for phospholipid fatty acid, every living organism has fatty acids in it. They can tell which is bacteria, which is protozoa, which is nematodes. Your PLFA test is going to show much better than your conventional neighbor. And that's a good thing. You'll get where you want to go much quicker. So you've got a lot of positives here. It's much easier for you starting with a farmer like this than a conventional farmer. Yeah.
But also the methods will probably be a lot easier, be more profitable for a conventional farmer, and if they can convert.
Yeah, but really, like Bill said, he's not getting enough premium on the organic to really justify it anymore.
Especially if you can find a higher premium,
Yeah.
uncertified market. That, I mean, at least I can. I'm not gonna speak for
Yeah,
everyone else
that
my
takes
age,
some
but
work,
like,
but
there's a
it's
lot
there.
of people my age that are like, and
You
not that
don't-
interested
you
in, like, also
condemn
don't believe in
glyphosate,
organic
though, the way it
Yeah,
sounds.
I don't-
anymore.
It's-
Like,
it
the
don't-
chemical
You will
stuff,
burn down
we don't
fields.
trust it.
Yeah,
I don't buy
You
it.
don't.
No, I
Yeah.
don't. I haven't had to do burn down.
He's the first one to tell
If
me
I
that
use a
organic
burn
doesn't
down,
count.
which doesn't occur very often, I've got a lot of fields that are 7 years of zero.
Uh-huh.
But if I do a burn down, it's going to be just with like a broadleaf herbicide or a grass herbicide, something else.
I say it's a
Now,
premium
glyphosate is, I would rather people not use it, but
shows it.
it's more important for them to use it and have grow successful crops than to not use it. The issue with glyphosate is it's way overapplied.
Yeah, exactly.
It's like